Hello, welcome to topic 8.3, area of irregular polygon. Shout out to my boy Aiden Bozak, who's in class with me this morning. All right, here we go. Figure ABCDE is a regular, let's see here, 1, 2, 3, 4, 5, pentagon. Really? Back to these? All right. O is the center, of course. We've already done a lot of this stuff when we did the angles of all this. Remember that? We did that whole lesson. OA is just like in a circle. It goes from the center out to the very edge of the shape. That would be a radius. OX, now this is a different one. This is different from the radius. This is a new word. And we're gonna label it little a, because the name of that is called an apothem. Apothem is what some people call it, but I call it an apothem with an O there, apothem. And it has a right angle. So you do need to know the difference between an apothem and a radius, because the apothem we're gonna use as a part of a right triangle, and it's gonna come out in one of our equations that we'll have today. Angle EOA, if I take two radius, just like in the circle, and they make an angle together, if I put two radii together like that, that is called a central angle, just like in a circle. Two radii make a central angle. It has a vertex at the center and has sides that pass through consecutive vertices. Okay, it has to be consecutive, meaning it has to go through E and A, and it can't go through like for example, this would technically not be a technical central angle because it doesn't go, it skips C. You know what I'm saying? Like this angle right here, skips C. All right, if we do some measures, so we do have to go back to the topic at the beginning of the semester. Measure of BOA, that is a central angle. And it's real easy to get the central angles because there are 5 of them. 1, 2, 3, 4, 5. There are 5 central angles in this picture. So to get that, you just do 360 divided by 5. So you just do 360 divided by however many sides there is, and that is your central angle, 72. 72 degrees. Now, XOA is half of the central angle. That's that angle right there, so that is just half of that, so 36. And then angle OAX, that's this angle right here. And this will be a test question. You have to find the central angle, and you end up having to find this angle right here. So find your central angle, 72, cut it in half, 36, and then has to add up to 180 in this triangle right here. So what is that? It makes that 54 degrees. All right, so you will have to work your way around the angles of any shape I want. All right, next, example 1. Assume regular polygons. Regular meaning all angles are the same, all sides are the same length. That's what we're gonna be working with in this lesson, these regular shapes. Find its central angle, then draw the apothem and the radius. Do you see any special triangles that show up? Let's see. So if I were to find the central angle of this, I just take 360 divided by 3. 360, why am I doing this in my calculator? I can do that in my head. 120, central angle is 120. And then we can label, if I go straight down at a right angle, that's an apothem and that's a radius. Okay, same thing here. All right, we know about the diagonals. These are just diagonals of this quadrilateral. These are all right angles. 360 divided by 4 is 90. And so drop it down, that's the apothem, and that would be a radius. And in this case, we do have a special right triangle. This triangle right here must be a 45, 45, 90. So root 2 is going to get involved with this triangle, right? This is a 45, 45, 90 triangle right there. We already did pentagon above. And so we know 360 divided by 5 is 72. And when we drop the apothem down, apothem and radius, there we have it. Not a special triangle, just regular. Being that this is not a special triangle, if you have to work with this triangle, it's going to be a SOHCAHTOA problem. Oh, and I forgot to say here, look at this one. This is a 30-degree angle right here. That's got to be 30, so this is a 30, 60, 90. So I would expect root 3 to be a part of that one. Over here we have the hexagon, one of my favorite shapes of all time. Also one of nature's favorite shapes of all time. If you take 360 and divide it into 6, you get 60. And this itself is a perfect regular triangle, which is kind of cool. So this triangle is inside of right here, which is neat. Which means if I drop a apothem in there, I do get another 30, 60, 90. There's a 30, 60, 90. So we're expecting root 3 to be popping out of that at some point. And then lastly, we have the octagon. I mean, we can do this with all polygons, but that's all I got room for. If I take 360 and divide it by 8, I get 45. Central angle is, this is 45. If I drop an apothem, that's an apothem. That would be a radius. All right, so apothem always have right angles. Okay, so now, what is the area of one of these? How do I find the area? We know how to find area of triangles, so we could do that one. We know how to find the area of parallelograms, so we could do that one. We don't know how to find the area of these, but all it is a bunch of little triangles, and so we can figure that out. And it turns out that the area of a polygon is 1/2 times its apothem times its perimeter, where A is the apothem and P is the perimeter. All right, so there's your magical formula. It is a magical formula until I show you where it comes from. So watch what happens. If I take, I'm just gonna draw a shape, and I don't know how many sides it has. It just has n sides. Okay? Has n sides. There's 1, 2, 3, 4, 5, who knows how many sides. And we're gonna say that each side is S. Okay, each side has a length of S. They all have a length of S. And all we have to do is we're gonna drop an apothem in here, and then we're gonna make a right triangle. And we can find the area of a right triangle, right? We can find the area of that triangle. In fact, let's do another one. Let's find the area of this whole triangle. This whole triangle, the area of the little triangle is 1/2 base times height. Now, in this case, the base is S. And the height is the apothem. If I were to find the area of that, I'd do 1/2 S times A. And then how many of these triangles would there be in this shape? You get one triangle per side, right? So however many sides, we're gonna say times n. All right, so that's how many sides times n. And now if I rearrange this, 1/2 times my apothem times the number of sides times the side length. Now what's another name for the number of sides times the side length. It'd be called perimeter. So there you have it, 1/2 apothem times perimeter is what pops out. There's a little bit of an explanation for you. All right, example 3. We are finally going to do a problem. This is about as basic as it gets. This is just plugging in. I call this an easy one. Find the area of the regular polygon. That's the word we're looking for. And here we go. Area equals 1/2 apothem times perimeter. The apothem is 9.7. Look for that right angle. The perimeter is 14.1 times 5, because there's 5 of them, so the whole perimeter is that. Now we can plug that straight into our calculator just like that. And 341, I'm just gonna round it to 342. It does say nearest integer, which means no decimals. 342, and we're just gonna say units squared, because there are no units given. So we'll say 342 units squared. All right, next one. Now, this is a triangle, and you could use 1/2 base times height, but we don't have the base, and we don't have the height. What we do have is the apothem. So we already have half of this equation. We just gotta figure out the perimeter. Apothem is 4. And now perimeter, and I'm gonna leave that open a little bit. So going back up to here, what kind of triangle is this? We can go back up to here. That's a 30, 60, 90. This one, it's a 30, 60, 90. So that means that this is 8, and it makes this 4√3. Yep, that's gonna come back into play. This leg is a little bit bigger than this leg, and it's related with the √3. So how many of those 4√3s does it take to get around the triangle? How many 4√3s? 1, 2, 3, 4, 5, 6. It takes 6 4√3s. So there's my perimeter. That's my perimeter. All right, now we can plug that into the calculator. Actually, maybe we can do it just by hand here. Half of 4 is 2. 2 times 4 is 8. I'm gonna skip the √3. 8 times 6 is 48. So this is the exact answer, 48√3. I didn't have to plug in my calculator. Now I can plug it in my calculator, 48√3. Oops. 48√3. We're gonna call that 83. Units squared. All right, next one. We have a hexagon, and the only option for this is 1/2 apothem times perimeter. We don't have the apothem, but we basically have the perimeter. It's just 8 times 6. 8 times 6 is 48. What do you gotta drop? We're gonna drop an apothem in here. There's an apothem right there, which makes, if this length is 8, then we're gonna split it, and it's gonna be 4. And this ends up being a 30, 60, 92, and it's the same one as this one. This is 4√3 again. It's 8, there's our apothem. It's that 4√3. And there we have it. Half of 4 is 2. 2 times 48 is 96. We'll call it 96√3. Plug in our calculator from here. 96√3 is 166. All right, now this next one is a square. Now for the square, you got all kinds of options. You could use base times height. You could use a rhombus, because a square is a rhombus. Or now you could use 1/2 apothem times perimeter. You got all kinds of options for that. So you have to decide what is best. Do I have a base and a height? No. Do I have an apothem and a perimeter? No. Do I have the diagonals? Yes. I do. These are all 15s. So you gotta think smart here. The diagonals will just be both 30. So that's 900, that's 450 units squared. Okay, think smart. Think smart, not hard. All right, on to part 2 of this lesson. These are composite figures and shaded area stuff. So here we go. How do you take care of something like this? This is not regular. This is a 1, 2, 3, 4, 5. It's a irregular pentagon. So how do you figure this out? Well, you can split it up. All right, you split it up. And now we have a rectangle and a trapezoid. You can do that. So this is a 5 by 15 rectangle. All right, 5 by 15 is, what is that, 75? So what I like to do is 5 by 15, 75, yeah. I find the area and I circle it. Kind of helps me to keep things straight. I do have to find the area of this trapezoid. So to find the area of the trapezoid, first of all, figure out what this is. This would be our height. It's 12 minus 5. This is a height of 7. 7 and 5, right? So to find the area of a trapezoid, you average the bases. We're gonna find the average of these two. 8 plus 15 divided by 2. There's my average. The average of my bases is 11.5, and then you multiply that times your height to get 80.5. So this is 80.5, and now I'm just gonna add those together. 75 plus 80.5, 155.5. And that's what you do. When you come up to a shape like this, where it's not one of our nice formulas that we could use, you gotta split it up. So how do you split this one up? I'm gonna stop my video there. We're gonna have a part 2. Bye-bye.